recording, guys. I'm Dohan. Here is the sentence, so let's get started. In this video, we will start with SHAP library and then we are going through class confusion, and in the last part, we will discuss important aspects of doing research. So let's get started with our lesson. Let's begin with SHAP. So SHAP is a library used for explaining the output of machine learning models. It provides a way to understand the contribution of different features in making predictions. SHAP values aim to allocate the prediction of a specific instance among its features, considering all possible. To use it first, we need to train a model, so we will quickly train our adults model. Here we import the tabular module from FastAI. Then we grab our data by using enter_data method. And here we define our dependent variables, the categorical and continuous variables, our preprocessors like categorify, fill missing, and normalize, and our splits. Then we define our tabular pandas object and create our data loaders. Then we create our learner and fit for one epoch. So now we have our model. Now let's import the interpretability module. Here we import it. And now we will make a SHAP interpretation object. It expects your learner along with some test data to look at. And as you can see here, we create our SHAP interpretation and pass it our learner and the first 100 rows from the data. Now let's take a look at the various methods that are available to us. First, we have the decision plot. It helps to visualize how the output of a model is influenced by different features for a specific instance. For that, if you plot too many samples at once, it can make your plot illegible. Now we can take a look at the 10th row of our data frame. As you can see, the age is 23, our work class is private, and so on for the other features. And the output or our dependent variable, which is the salary column here, is below $50,000. So now we want to see how each of these features affected our model's decision in getting this less than 50K or greater than or equal 50K. So we will see how each particular value shifted the decision. Here we display the decision plot for the 10th row from our dataset, and we define the class ID here to be 0. So we take a look at the score for below 50K class, and if we want to use different class, we can specify the class ID to be 1, which we will see in a moment. For this plot, we can read it as the more in red we are, the more we are tuned for less than 50K, and the more below we are, the more we inclined we are to greater than or equal 50K. And here we plotted for greater than 50K, so we define our class ID to be 1. And the next plot that we are going to take a look at is the dependency plot. So the dependency plot essentially operates by plotting our age for an instance on one axis, and the marital status number here for an instance on another axis, and we can see the relationship from each of these different variables. So we can see when the marital status is high and when the age is high, how does it affect our data. So here we just call dependency plot and pass it our column, which is the age column, along with the class ID here is 0, so this for the below 50K. And here it is for the class ID of 1. Then let's go with the force plot. It allows us to see how each variable at a certain value affects whether it falls into class A or class B. For this plot, we will take a look at it into Colab. So here we call force plot, and pass it our class ID of 1. So this is for class greater than or equal 50k. And what I can do is just say age, for example, and look at how age affects our education. Now you can look at the number of affected samples and see how each particular age value affect the predictions. Now let's go with the summary plot. It's similar to feature importance. It shows the average impact of a particular value on a model performance. For example, the marital status here is the most important variable, where the age is the second most important variable, and so on for the other variables. And the last plot that we are going to take a look at is the waterfall plot. It explains one-row predictions in sort of how each variable affects the outcome, so it's similar to the decision plot. So as you can see here, we pass in our row index, our class ID, which as you can see can be a string, and we can take a look at how each variable pulled our outcome. And now let's go with the second notebook. In this notebook, we will take a look at ClassConfusion. It allows you to get insight into how your model behaved when it got things wrong. So first we have the confusion matrix, which tells us, for instance, there's 10 values were missed in this class and 40 values were missed in another class. And just like the previous notebook, we want to train a tabular model, and after training our tabular model, we will go ahead and create an instance of ClassConfusion. So here we import it. And in order to create the ClassConfusion instance, we can pass in any variables we want to use, any test data loaders we want, and whether our list of classes is ordered. So here we define our test data loaders to be the first 100 rows from our data frame, and then we define our class list. So first we have less than 50k, and then we have greater than or equal 50k. Here we call our ClassConfusion and pass it the learner, the test data loaders, and the class list that we have defined. First, let's take a look at how the working class distribution of my message was different from the original distribution. So if we take a look at the original distribution, we have mostly in private, then self-employment, local government, and so on. And the question mark here is our missing values. Then if we take a look at what sort of confused of less than 50k, we can see it mostly was people from the private sector, with a little bit from local government, and then if my values were missing. And for greater than or equal 50k, it's again mostly from private sector, self-employment, local government, and self-employment but not in corporate. And here's the distribution for education. So as you can see, here is the original distribution for less than 50k, and for greater than or equal 50k. Here's for marital status, occupation, relationship, and race. So this is for the categorical variables, and let's go with the continuous variables. For the continuous variables, as you can see, it shows the histogram of them, and the orange line here helps us to see what the bell curve looks like. So here's the distribution for the original, and as you can see, the curve looks different from less than 50k and greater than or equal 50k. And so on for the other continuous variables. Now let's go with the last notebook. In this notebook, we will discuss important aspects of research in a simple and friendly manner. So if you want to do a research, first you need to understand your data. Knowing the data well is like understanding the language of computer models. It's essential for using them effectively. Without this understanding, it's like trying to have a conversation without knowing the words. We might get by, but we won't really know why or how. Knowing both the data and the technique is like having a map to guide us. Then you need to understand the techniques. So if you are the person others turn to for help with the neural networks, it's important to be sure of what you are saying. You are the expert, but don't worry if it's tricky sometimes. Even experts face challenges because dealing with the neural networks can be like solving puzzles. And you need to make sure that you are creating a good test set. So creating a good test set is like making sure your model is ready for a big exam. It's how we check if it really understands or if it's just memorizing stuff. Getting this right shows you are really good at this. And the first step is interpreting the techniques. To some people, neural networks seem like magic boxes. They are powerful, but they seem mysterious. However, they aren't really magic, and we can understand them. The hard part is explaining them in a way that others can get. So it's like being a good teacher making complex things simple. And the last thing is just being responsible. So admitting mistakes can be hard, but it's really super important in research. It's just like saying, I got it wrong, let me fix it. So doing this early can save a lot of trouble later on. In conclusion, doing research is like going on an adventure. There are tricky parts, but every little discovery gets us closer to understanding more. Remember, in research, every small step counts. So that's it for today's video. Hope you enjoyed.